Ancora ospiti negli studi.
Back to our EIMA Web TV studios for this 45th edition of EIMA International. And we have here Professor Lorenzo Marconi from Field Robotics. Good afternoon and welcome. Professor Marconi, we're here for a nice chat. So when talking about electrical autonomous vehicle, what are we talking about? So at Field Robotics, this is a concept. You can have an electrical autonomous vehicle, which is the conventional one, or we can apply an innovative concept as we've been working on and developing at Field Robotics. We're talking about a small, versatile machine that can be easily reconfigured on the operation to be carried out. It is autonomous. There should be an operator on board, the operator being partially present in the system. So it's an open-ended machine in a way, meaning that we can develop implements in the future which are electrically powered and extremely precise and flexible, as of course can be provided by an electrically powered vehicle. So what's the kind of collaboration between human and machine? This is the most intriguing aspect of the whole project. In fact, we are developing an autonomous machine. I teach automatic controls at Bologna University, and it's part of my DNA. I've always been very interested in autonomous guidance, especially in particular environment as in agriculture, where we have the collaboration between man and machine, or human and machine. So there are some repetitive, boring operations that have to be carried out in agriculture, and that can be performed by the machine, whereas the human can take over when it comes to a more cognitive operation. And even though an AI-based system can be placed on board, of course a human operator has a performance that cannot be completely replaced. So collaboration means that human in certain applications such as harvesting is close to the machine and cooperates with the machine in harvesting and pruning, and the machine facilitates the process and its robotic support. So there's a term that I heard quite a few times over these first 2 days of the trade fair: electrification. And here I'm pretending I don't know what it's all about. What are we talking about? Electrification is present in the automotive industry. Electrification started many years ago, and it's become predominant. So the vehicle is completely electrical in terms of drive and energy reserve to be used for a given implement and a given operation, with a number of advantages. Of course, an environmental advantage, because if I use an electrically powered machine, I of course reduce emissions, and sustainability must be considered as a whole. So when from the moment a battery is manufactured to the moment the battery has to be, a spent battery has to be disposed of, this is something that lay people have to know, how to dispose of spent batteries. There's a second life for these batteries in domotics and different applications where energy efficiency is present but not optimized. So electrification revolution presents a number of advantages. Lightweight machines, for instance, easy to clean machines, easy to maintain machines, and expandability of the machine. So we're increasingly going to see fine-tuned operations which are normally carried out indoors in other areas of engineering, which will be brought outdoors. Precision movements, precision motion required for those applications is not totally not compatible with an endothermic kind of vehicle. So it's a total revolution, and it's very challenging from an engineering viewpoint. They're not toys. These machines, to be able to perform, must be sturdy in order to be operated in environmentally challenging situations. So it means a lot of technology, a lot of study and research, and then it comes to training. And being a university professor, I feel particularly intrigued by that aspect of the educational side of it. In fact, we need technical training, accounting for different mechatronics. So compared to the other machines, we have to reinvent a whole class of designers, manufacturers, and after-sales people, experts, that, they were originally trying completely different technologies. And then we need to train the final users, people that maybe have been used to dealing with certain issues and operations which will no longer be performed in the same way. So the technology is new and the approach must be different. So we need to provide a comprehensive training. So where the academic side, which I'm mostly involved in, has to be combined to the future operational challenges. For instance, I insist with my students that they should consider a technological challenge. I'd like to take this opportunity of having you here with us. There's a silly question probably coming to my mind, but I don't think so. I'm thinking of surgery and medicine. Medicine doesn't travel alongside surgery. Does training proceed hand in hand with technology? Well, I'm thinking of the education, of the academic education, that should never be separated from real-life issues that are experienced in different production sectors, different industries. By tradition, the Italian universities have been sort of ivory towers, so not very interested in industrial requirements and innovations. But now I'm seeing more interaction in developing curricula, for example, a closer contact between manufacturing and university and the academic community. And I'm actively involved in this revolution experienced by the universities, so we'll have a more professionally oriented degree courses, and where real problems will be taken into account and will be part of the curriculum in order to develop professionals that are able to deal with real-life issues. As well, I've taken up a lot of your time, but I thought the conversation was very interesting. I wanted to get into this. Thank you very much and enjoy the aim and good luck for your work. Thank you.